For this experiment, we're going to be creating what we call a sugar rainbow. And what that involves is dissolving different amounts of sugar in the same amount of water. We're going to be comparing what they look like when we layer these different sugar solutions and exploring what their densities are going to be. The materials we're going to be using for today's experiment include the following. Definitely need some sugar. We are going to be using 4 glasses right here. You could also be using 4 beakers or 4, even bowls are fine too. We've got our water, since we need to mix and dissolve the sugar in the water. We've got our food coloring. This will help us identify the different sugar solutions we've created. We're going to be using this small graduated cylinder to show the layers of our sugar solutions. A spoon to mix the sugar in the water. This is going to allow more interactions. And then we've got some pipettes here that we're going to use to transfer our sugar solutions to our graduated cylinder. We're going to lay out our 4 cups. So we are going to be using the same amount of water for all 4 solutions. The only thing that's really going to be different is the amount of sugar that we put. Our first solution is going to contain 1 tablespoon of sugar. Our second solution is going to contain 2 tablespoons of sugar. And then lastly, for our 4th solution, we are going to have 4 tablespoons of sugar. Now that we've mixed and created our sugar solutions, notice how for our first container, it looks like most of the sugar has dissolved, but our last container over here does not have all of the sugar dissolved. So when this happens, what we'll just have to do is add a little bit more water. And again, we're gonna evenly do that. And then let's mix again. The reason why we mix or use a spoon to stir our mixture is we really want to allow these sugar molecules to interact with the water, because the water is what dissolves our sugar. Now, in order to be able to identify these 4 solutions, we are going to add food coloring. We will place the pipettes in each of these solutions, mix them up. Now that we've created our 4 colorful solutions, we are going to get our graduated cylinder right here, and we're basically going to put small amounts of each and observe for any layering. If something is the most concentrated, what that means is that you have more moles or more particles of your solute, which in this case, the solute is sugar. Let's check it out. We just need a few drops. Okay, we've got the green. Let's take a look at the red. We're gonna slowly add it on. This next solution has 2 tablespoons of sugar. So notice how you're seeing your green, red, and blue layer. And then lastly, let's check out our yellow. You see our 4 different colors, which means we have 4 different layers. And the reason why we are seeing the 4 different layers is because of the change in density. So your green solution that contains the most amount of sugar is going to be your densest substance, which is why it's on the very bottom of this cylinder. Meanwhile, your yellow solution will have the least concentration, and because it has the least concentration, it's going to have the lowest density, which is why it floats to the very top of our cylinder. We're going to take this a step further and observe what happens when we add a little bit of water to our column. And so notice how you actually won't see any of that water layering, because again, we know that sugar dissolves in water. So the sugar that is in the yellow layer wants to interact with more water. And that is the reason why we don't see a clear layering, because that water that I just added has actually mixed with our yellow sugar solution. For this experiment, we explored the different densities of different sugar solutions. We learned that your most dense solution is going to be the solution that contains the most sugar, and your least dense is going to be the one that contains the least amount of sugar. For more colorful and exciting science experiments, make sure to follow us here at Expulsion Science. We'll see you later.